On this week's NFV SDN Reality Check, we speak with Radisys on the connection between 5G and the telecom industry's core design efforts. All right, thanks for joining us on this week's NFV SDN Reality Check. I'm your host, Dan Meyer, Editor-in-Chief at RCR Wireless News. And this week we are joined by Brian Sadowski, who's the VP of Product and many other things at Radisys, to talk a bit about the company, but also about the initiatives behind Cord and MCord that are happening across the telecom space. So Brian, hey, thanks for joining us again. We appreciate it.
Yeah, thanks for having me on. It's always a pleasure.
Very good. Well, I know we talked probably almost a year ago now, and it seems that a lot has happened in terms of Cord, which for those who don't know, Cord is it is the central office reorchestrated as a data center, I believe is the acronym's title or official name. But a lot's been happening in that space, and I know Radisys has been central to a lot of that there. So maybe I thought we'd start off with just, for those who don't know much about Radisys and maybe didn't watch our last video, which I can't believe you wouldn't have watched it, but maybe if you didn't, maybe a little background on Radisys from you, Brian, just so we have a little kind of background there for everybody.
Sure. Yeah. So Radisys has been around almost 30 years. So we're a company that's gone through a couple of transitions, and over the years have picked up a few different companies that have given us some expertise in various places. And as it turns out, if you look at the Cord architectures and all the open source movement, we've been able to utilize some of the expertise that's come along. So we had, our legacy was very much on the hardware layer, so embedded products, ATCA chassis. And as that business is sort of wound down, we've wound up by embracing open source. So where we have a product line called DC Engine, which provides open compute-based compute, storage, and networking in a rack-level platform. So what we did is we joined Open Compute Foundation, which was started by Facebook, and we took a look at OCP, what Facebook had brought in there, and Microsoft and others. And we realized for the central office, for the carrier space, there was some piece parts that didn't quite fit. You needed, EMI, you needed flexibility with where the power comes in, you needed, vibration capabilities, potential to go to NEBS certification, whereas OCP, none of that. OCP was designed for very large warehouse scale data centers. So we had to take a look at, central offices are smaller, they can handle, 50, 20, sometimes 10 racks, and how do you accommodate that? So we modified the OCP, took the best of OCP and then modified it to suit the carrier needs. And that, we submitted back into OCP, and it has become what's called CG OpenRack 19 is the specification that was recently accepted by the OCP Foundation. So we're very excited about that. And what that does is that actually gives you the foundation for all of this virtualization that's coming. So as you take a look at open sourcing various levels of software and virtualizing a lot of network functions, you need somewhere to place it on, and you need it to be robust and scalable and reliable for the carrier. So that's where our DC Engine product is, a commercialization of the OCP CG OpenRack 19 spec. So that's one piece of the puzzle that Radisys brings to the table. We also picked up a company, Continuous Computing, many years ago, and they had protocol stack. So it was the old Trillium protocol stack. Oh, yeah. So we build a lot of, eNode Bs and small cell, and we do a lot of custom development services. So a lot of, consulting services to wrap those protocols, to wrap applications around that. And where that comes in is as we start moving towards 5G, a lot of this LTE capability and the 5G stacks, the EPC, the RAN stacks, are the carriers want to disaggregate those. Yeah. So if you take a look at the vendor core, if we look at the DC Engine hardware and how we disaggregate, and now we have commodity compute, we're using standard motherboards, we're using standard NICs. Basically we've stripped out control data plane, away from the hardware, and it runs on standard COTS. The RAN is not like that today. Mm-hmm. And that is really what's starting to happen, is they want to break apart the software and the hardware, and they want to break apart the software from the control and the user plane. And so we have a lot of expertise in that. And so we actually had a test-based EPC code base that when we joined the ON Lab, which is the core central office re-architected as a data center, we open sourced our EPC for testing. That gave a foundational code base that the community can then work on to disaggregate P gateways, disaggregate control from user plane.
Mm-hmm.
We also, right before Mobile World, we announced we open sourced our RAN stack that we use currently in small cells, so our ENO-B stack. So that is going to allow us now, and with the community, to really start to take apart the RAN and to provide an open source base that you can add vendor proprietary elements on top of it, but some of the core elements like mobility management can be broken apart, and it's going to be very important that you do that for resource utilization enhancements and efficiencies. Mm-hmm. So that's a piece part that we're working on. Another big piece part, we have a flow engine product line, which is really an SDN enabled, very high speed data plane switching fabric that goes above, goes layer 2 to layer 7. So that, and the reason why we came out with that product a couple of years ago was we wanted to be able to have more granular network slicing capabilities. And really, in layer 2, layer 3, it's VLANs, VXLAN, right? You're chopping up the network into various VLANs, but we wanted to go based upon flow classification, based upon higher levels. So maybe based on the protocol or based on some regular expressions to be able to segment out the network and isolate certain parts of the network. And so that is our flow engine product. And so when you take a look at now, fast forward now, and we start looking at the 5G network, this idea of network slicing is a big component of gaining efficiencies within the RAN. So our flow engine product line is a commercial manifestation of the ability to network slice based upon subscribers, mm-hmm. right? Or other attributes that are more granular than just a layer 2 or layer 3 addressing scheme. So if you take those piece parts together, those are the pieces of the puzzle that I control within Radisys, and they're all sort of starting to come together where you have this open compute, open commodity-based hardware which drives down costs, and it becomes a very homogeneous platform that you can now lay on a bunch of open source software for the foundation, the platform layers, and then you can add in vendor-specific software on top of that. And then the last piece is, our work in the core is to integrate it all. So it's one thing to have open source software and open hardware, but how do you get it so you can deploy 1,000 of these, right? There's a lot of work that you have to do to make it scalable. So those parts are, are the piece parts that Radisys has been working very hard on over the last 6 months to bring together so we can actually deploy some of this stuff that's going on in Cord and TIP and other places. We can start to really, move from proof of concepts into real field trials. So so those are the big piece parts. And then we have another piece part that is currently a different part of the organization, which is our media engine product line, which we have, today we do, we own 60-70% of the conferencing market as far as the back end media resource functionality, mm-hmm. As well as, we are doing now adjunct transcoding for carriers to lower the cost, so centralized transcoding capabilities. And even that piece, even though that is a separate component within Radisys today, we have a virtualized version, mm-hmm. which is a VMRF. And lo and behold, when you look at the Cord, you look at our DC engine, well, you can take that software and run it as a vendor-specific VNF. So that's how all the pieces are coming together within Radisys.
Interesting. Yeah, and I will say I was at the recent Open Compute project show out there in San Jose. I think you were there as well, but I would say Radisys definitely had a pretty good presence there. I think all the telecom focused kind of sessions that were going on there, you guys were definitely a big part of a lot of those. So again, a big part of that open source kind of programming out there that's going on. So it's kind of good to see you guys out there doing quite a bit as well. So.
Yeah, no, we're very pleased with this shift that's taking place. I mean, from our perspective, we view this open movement as something that is it's very new, but for all the existing companies out there, there are so many there's so many vendors in this space. Wrapping your head around what it really means to become open and not hold that IP tight is it's a very big change in mindset that has to occur within the industry, both vendors as well as on the carrier side. And we're in the very early days of that. And, I feel pretty lucky at Radisys. We did a lot of hard thinking at the exec and at the board level to really start to think through, how do we monetize this, and how do we not get steamrolled by someone else? And but at the end of the day, as you saw at the Open Compute Summit, we're gaining a lot of traction. We feel like we're in a position now where we're starting to be ahead of the pack. So we're helping define where the industry is going, and I think it's great for the community, and it's really going to be such a big change over the next 5-10 years, and we hope to be right in the front of it.
Yeah, well, I guess before we jump into the core aspect of this, I guess in terms of that open source, are you finding that the other vendors out there, the ones that you guys are working with, obviously in a lot of these projects, are they getting a better handle on the need to embrace open source? Because like you said, there are a lot of entrenched, established vendors out there who have had this history of, very, IP centric. They control a lot of their own software and hardware out there. And that's been kind of an ongoing issue. Does it seem like is that trend starting to turn a bit where operators or vendors are getting more open to that, or are there still kind of holdouts that are maybe, still needing to be convinced, I guess?
Yeah, so I think there's various companies in various stages of admitting this change is occurring. Some of the bigger TEMs, they have a bigger problem on their hands. I certainly understand their position.
Yeah, sure.
They have certainly woken up to the fact that, Cord, M-Cord, open source EPCs, open source RANs are no longer a toy that's relegated to the lab. They are very keen on understanding where this thing is really going. Now, and to be open, they understand fundamentally what they need to do, and there are piece parts that they are becoming much more willing to do. And I think so intellectually, they understand. It's culturally within the organizations. How do you transform your company and get everybody behind you and on board? And that's actually, quite frankly, the hardest part of this transition that's taking place. It's, technologically, everybody understands.
Yeah, that's a good point. And it seems like that's also what operators are going through themselves. All the big guys, they're all behind this open source initiative, but it is a long transition because it is a lot of retraining of their workers. It's such a big, monumental cultural shift, like you said, for these companies, that the vendors are on the same boat, especially the bigger vendors, because they have so many employees and so many divisions, that it is, like you said, a kind of a big challenge for everybody, especially if you've got a large scale like that, to really change everything on the move, really.
Yeah. No, there's definitely this notion, they're trying to, you have, typical silos in the big carriers. You've got operations, you have engineering, you have architecture, and, for the most part, the architects, they totally get it. They're out there pushing. The engineering folks are on the page now. The operations folks need to be brought in. So, half my conversations with carriers are, we get in these meetings and, we're all talking the same language and everything is good. But I'm like, where's the operations people? Where are your ops people? And, and they sheepishly, and some of them are in different stages than others. But at the end of the day, they know that's sort of the biggest piece of the puzzle that they need to integrate in. And once that happens, I think you'll really start to see even more movement. And it is happening. It's just, different carriers are at different stages.
Yeah, exactly. Well, I guess moving on the topic of Cord and M-Cord that are kind of happening. Obviously, it does seem like over the past 3 to 4 months, there's been a lot of announcements in terms of a lot of open source work, a lot of carriers getting more involved in this process. I guess maybe from a higher level, and we might have already discussed this on the previous interview as well, but I guess what are your view as the benefits of the industry kind of moving towards this kind of core architecture? And then we can kind of dive in a little bit more on kind of the, what's happening in terms of these different initiatives. But what are the big initiatives? What are the big benefits at this point of moving towards a core platform? So
there's certainly, obviously agile and cost-efficient deployment. So the real benefit, there's two pieces that I see that make up whether this makes sense to do or not. One of it is, service velocity, and the other is, cost efficiency, right? So if the new solution doesn't bring costs down and enable you to deliver new services almost instantaneously, you're going to run into friction, a lot of friction, because it's really about revenue. It's about increasing your revenue and decreasing your costs. I mean, at the end of the day, it's really simple. It's a simple process. So how do you decrease costs? Well, you go to commodity, right? OCP is one big way, because, the typical vendor model was you had a monolithic hardware, software, model, and you could then have high margins based upon the whole solution set, and that's getting broken apart. So now the hardware margins are commodity margins, which are much, much lower. So that's a big way. Open source software, obviously, you're not paying nearly the licensing fees that you have. Now, there are other costs. There's integration costs that you have to pay for. That does come in, but it allows you to innovate at the platform level far more quickly. And then, building, a virtualized framework, whether it's VNFs with OpenStack or whether it's microservices with containers, with Docker or other, LXD containers, putting that framework in place is sort of step one, right? Dropping a VNF down for a new services, it becomes much faster. You don't have to deploy hardware. You don't have to train the operations staff on how do you swap blades and all of that stuff. So that becomes much easier for them from an operational standpoint. But really what makes this sort of accelerate is the ability now to wrap automation tools around it. So from a platform side, you want to be able to move from a very waterfall-like focus. So when a carrier wants to deliver a new service, I need to upgrade my switches and routers and this and that, and I need to go through this massive cycle of testing, and it's a 9-12 month process, so it's 2 months for the new service. So with this new framework, what you need to do is you need to build in automation tools so that upgrading is part of the network, not an adjunct event that occurs once every 9 to 12 months with a million features. So, and that fundamentally shifts the entire network. So if you look at the way data centers and DevOps operates, that's how they operate. If you look at the Facebooks and Googles and Amazons of the world and Microsofts, upgrades are going on constantly. Right? The networks are constantly being upgraded. And you can't do that with human intervention. So you have to build these automation tools that allow you and an analytics framework to be able to run through testing with a new image, either give it the go or give it the no go, based upon error results, to be able to roll through the network. And it's a continuous process, so it's all part of continuous delivery. And what that allows is now they can focus on building new services, new applications, and they can do it in small subsets. So they can start to do A/B testing. They come up with a new idea for a new service. They don't know if it's going to be good. They've got 2 different user designs. They throw them both out there. Do testing, get the results, iterate. Next month, they can do another version. Next month, they can, and then when it starts to gel, they can then take that and then expand the scope and widen it out, right, from a global perspective. And when you have a homogenized platform layer, you can do that. You can accelerate it, you can decrease it, right? Same thing with upgrades. You can upgrade, you can downgrade, because you're doing it continuously. So this is the framework that Cord, one manifestation, allows these carriers to get themselves in. And it's not just in the big monolithic data centers, which they're all in some way, shape, or form doing OpenStack or whatever. It's pushing that closer to the edge and utilizing these vast assets they have in the central offices to be able to get closer to the customer and still have the same framework. So now I can do an AR, VR, I can do a telematics app. I can drop that down close to the user and get better quality of experience than a Google or a Facebook or some other over-the-top provider, because they're back in the big data centers. There's a lot of latency. So those latency considerations are a major factor, or packet loss or jitter. That matters. And so this is the way that they're going to be able to have now advantages. But it all comes down to building that foundation and getting that data center extended out into the edges, and then building these automation frameworks so that when you lay down the service, it can jump out there immediately. So those are some big pieces. And then it's a matter of, you want to make sure that whatever framework you put in place you can enhance your resource utilization. So this ability to slice and disaggregate. So as an example, if you look at IoT, right? IoT is going to put massive pressure on the MMEs, right? And 9 times out of 10, the IoT is static. So it really doesn't need mobility management. So why not separate out session management and mobility management, right? So then you can have, a separate IoT gateway. It's really an SDN-enabled switch. The RAN now can, as it sends messaging up to the virtual MME, the virtual MME has the info anyway, and it knows, oh, this is a static IoT. I want you to just send it. So you don't use up resources on mobility management and the serving gateway and the packet gateway and the controller. Doesn't need it. So things like that are really where as you virtualize, you can break apart. And the open source movement is allowing a lot of this, because now the carriers get a big say in what happens in the network. And so that's kind of the big shift. But, without all the other pieces that I talked about, this is not going to help you very much.
Yeah. Yeah, it's interesting. I remember actually from the LCP event, I know there was someone was discussing the fact, the link between kind of the data center and 5G, and the fact that, what you want to do is do this asset reallocation or asset utilization, where you're kind of putting different sleds, number of sleds in a smaller and smaller number of sleds as you get closer to the edge of the network, basically. So, an operator can have, 10 sleds and a switching center, maybe one sled at a small cell somewhere, or even less than that even. But the ability to kind of stretch it out that way and get it closer to the edge, like you said, seems to be a big part of 5G, obviously, but it seems like cord is a big part of that process as well.
Yeah, I mean, the whole idea behind the cord project is to build a blueprint, right? So that you can have homogeneous framework platform, no matter where you are, whether you're all the way out to the edge on a single server board that's acting as a mobile base station, or bringing it back to one of the central offices where you might need a half a rack's worth of compute and networking. You may go to a distribution center where you need 3 or 4 racks because you're serving 10 or 15, 20,000 subscribers, and you want to be able to be modular, but you want that same operations framework across the board. So you don't want to have a closed unit that's using a different version of Kubernetes for microservices, and then you've got OpenStack in one section, and then you've version X, and then you've got version Y using VMware, and that is going to create a lot of havoc for them. And so they you really want to have some homogeneity.
Yeah, well, I guess is the market and the is the community, I guess, able to provide operators today with a platform that they can actually roll out with and feel comfortable with? I mean, is it carrier grade at this point? Or are we going to have issues where operators who might be kind of early to the game might be rolling out a certain platform that down the road might have to then try to be reintegrated into a newer platform? And I guess, where are we at in terms of the timeline in the evolution of having all this, I guess, commercial ready and carrier grade ready, if that's the right word for it?
Yeah, so as far as M-Cord goes, the M specific, we've got a little ways to go. I mean, it's this year is going to be doing lots of lab work, POCs, really, sort of doing the work necessary to really disaggregate the different piece parts of the RAN, figuring out, how to break that apart and compartmentalize it properly. As well as looking at the 5G standards, because they're not quite ready yet as well, and how do we modify that? But from the looking at it from a cord perspective, when you look at residential cord, or really it should be called access cord. So if you think about XGS PON or NG-PON 2, or some of the newer 10 gig fiber technologies out there, that's getting much closer. So and the beauty is, throughout 17, and we're involved in a couple of trials right now for our cord. And really the only difference is R has a virtual OLT, it has a virtual router, it has a couple of VNFs that are slightly different than M. You've got virtual MME and virtual PGW. So, but all the underlying foundational components, the Linux, OS, the hypervisor, the OpenStack, the in the cord case, the ONOS SDN controller, and then the pod orchestrator or the XOS service orchestrator that then interacts with eComp or, the recent, eComp/OpenO. So it's getting those northbound API hooks into there to abstract. Those layers down below are, pretty rock solid. I mean, we're using Ubuntu. Ubuntu is rock solid. It is, it's all a matter of, getting, Ubuntu with Docker, with OpenStack and, and ONOS together, right? And then XOS is another layer on top of that, but getting that hardened. So how do I get that as a easy to deploy package or a couple of packages? How do I upgrade it? How do I validate it? So that work is currently we're in the depths of that right now. So I would say, we will be doing real field trials come, second half of this year. For our cord. M-cord, like I said, will take a little longer, but all that foundational stuff, it's part of M-cord is just different VNFs. So you could conceivably look at a scenario where you could start with our cord and then move to, quote unquote, a hybrid cord where you've got R and M together on the same platform, which is really the ideal. That's really what all this virtualization is for in the first place. So I think, the platform part of it, we are, heavily moving towards a very scalable, reliable platform. And Radisys is providing, service capabilities to manage and maintain those distributions. So that the carriers have someone to point to, and we're gonna make sure that everything is validated.
The throat to choke kind of thing everybody wants to have.
Yeah. So because I mean, eventually they'll take some of that in house, but there's always going to be over the years, there will be a number of stuff the vendors will do. There'll be more and more that the carriers will do in house, but at the end of the day, they're going to need both. Yeah.
And it seems like coming out of the Mobile World Congress event. Again, it seemed like more operators are getting involved in this process as well. I mean, I know initially with Cord, when it was launched, a lot of operators were involved anyway, but it seems like over the past 9 months or so, it's really kind of gained a lot more momentum in terms of more operators getting involved in this too, which I'm guessing for you guys is probably a positive, having their input as this all goes along. Because again, end of the day, they're kind of the real customer of all this. So I'm guessing that's the process along as well.
Yep. Yeah, we have a number of operators very interested in both R and M cord. There's a few interested in enterprise cord. Enterprise cord really is a derivative of the R cord. It's just a different, it's just Metro Ethernet. But yes, there is a significant uptick in activity. And I think a lot of it comes down to, the carriers fundamentally recognize, they look at Google and Facebook and Amazon and Microsoft, and they look at those guys and they're like, man, those guys can come out with new services daily. How do we get there? And if you look at how their networks are deployed, Google's 80% open source and 20% vendor closed source. Carriers are the opposite. And part of the innovation is around, these open source piece parts, they can be iterated on very quickly. From the community, from internal, and they get new ideas, and so those can actually, you can add new capabilities to an open source platform a lot faster than you can getting 6 vendors to work together to get everything structured and working properly. It's just a lot faster. So that's ultimately this shift that is causing the carriers to be extremely interested in the stuff Cord is doing, because now they're going, hey, now I can get more open source, and and those platform components, there's really not a whole lot of value in proprietary code. So therefore, Mr. Vendor, you have to find different places to find added value, because if I can do roughly the same thing in open source that you do in closed source, then your closed source value is no longer valuable to me. So what they're looking for is, stop that, move to more value added services so that we can innovate better, and and even better, contribute your stuff back to the open source so then we can all contribute together. It's a very different model.
Yeah, that's for sure. Again, like you said earlier in the conversation, it's definitely a lot happening in terms of how vendors are approaching this whole space now in terms of using open source obviously. So yeah, a lot of changes there. And again, it does seem like the networks of today for the operators are going to be so much different 5 to 10 years from now. I mean, between this move towards virtualization and 5G and everything else that's coming along, it seems like these networks that have served the telecom space for the past 30, at least on the mobile side, at least the past 30 years, are going to be vastly different. Maybe not 5 years from now, maybe 10 years from now, perhaps there'll be huge changes and we'll have that kind of hybrid model for a while. But at some point, it's going to be a lot different out there. That's for sure.
Yeah, I mean, I kind of view it as, back in the olden days, in a various company, it was in the late 90s, it was when voice over IP, core voice over IP came. And I may have mentioned this in the last call is, you had the bellheads versus the netheads, right? You had all the ISP guys, that were all hot and, doing all this cool stuff. And you had the bellheads, which are very much 5.9s. And those two came together, and those are two different cultures that crashed together. And obviously the netheads won. I don't want to say won because they inherited some of the bellhead stuff, but then they became IP core infrastructure. Well, now you've got these data center guys, the web guys, the DevOps guys, coming together, encroaching with IP core infrastructure. And at the end of the day, the writing's already on the wall. The web scale infrastructure guys, the data center guys and gals are going to win out in the end. And the network they're just going to keep clawing at the network. And so that culture class has started. I think, or at least Radisys feels that infrastructure is the infrastructure of the future, and it's very much a flattened leaf spine architecture with compute, and storage, and how do you segment and work in that environment is going to become far more important than some of the existing IP core infrastructure models that have gone on over the last 15, 20 years. Yeah. And so I think I'm a pretty strong proponent within our company that that is the model we're going to get to. So 5 to 10 years from now, that's, I think, where we're a lot more networks are going to look a lot more like data centers, data center architectures. And so how do you enable them to do the things that you're doing in the IP core more efficiently at the end of the day?
Yeah. I think everybody realizes where we need to go. It's just a matter of how do we get there and how much bloodshed is along the way. But it's going to be definitely a challenge, that's for sure. So
yeah, definitely.
Media is to cover, but I know if you guys having to work behind the scenes there, I'm sure there's a lot of stress going on there. But hey, I guess it's part of the process. So.
It's part of the process. Yeah, I mean it's going to be interesting. I mean, we even have there's even there's little things going on. Like our flow engine uses a CLI, like every switch and router out there. Well, in the data center, they don't want a CLI. They're like, I want it to look like a Linux server with a lot of ports because I have all these Ansible scripts that I use. I have all the scripting that I can automate. And why do I want to have to change that? I'm in thousands of servers every day. They're all running Linux. Why would this be any different? And that is a massively different mindset, right? Yep. Even though it's a little thing, yep. It's a huge change. And when you start to think about it, that's when you realize, okay, these guys in the data center are onto something.
Yeah.
And there is going to be a big change. And that's why Facebook built their own FBOSS and, their own NOS because they needed to get there. Google did the same thing. And, and it was very difficult even for them to transition because you've got a lot of muscle memory. You've got a lot of expertise in dealing with, iOS or Junos or whatnot. And at the end of the day, it's Linux.
Yeah.
It's going to become Linux and you program it all with Linux. And it's like, what? This is foreign for some people.
Yeah. That'll be interesting to watch how it plays out. But well, Brian, we always appreciate you stopping by, give us an update on what's happening with Radisys, but also and the core initiatives and things like that too. So definitely appreciate the insight on that. Obviously, I think there were some topics here we could have covered for another couple of hours, but we'll save everybody from having to watch all of that. But again, always appreciate the time and insights, and hopefully we'll touch base again soon.
Yeah, thanks. It's always a pleasure.
Well, thanks for watching this week's show, and make sure to check out our next NFV SDN Reality Check when we speak with Sprint COO of Technology, Guten Ordendorfer, on the carrier's NFV SDN plans. Thanks for watching.
NFV SDN Reality Check with Dan Meyer is a production of RCR TV. To suggest show topics or to reach Dan, you can find him on email, dmeyer@rcrwireless.com, and on Twitter @Meyer_Dan. For more Dan, news on NFV, SDN, and everything wireless, find your way over to rcrwireless.com.